Another question which will need visualization, given to you are two lines L1 and L2 given like this and this. What do you understand? If a line is given to you like A vector plus some parameter times B vector, what do you understand is that this is the point where your line passes through, and this is the direction ratio of the same line. So now this is your line L1. Now what can I say about that? Let's draw it. Okay, let's say this is your line L1. It passes through. Can you see, instead of A you have nothing. So it passes through 0, 0 and 0. What are the direction ratio of this line? Can you see? Lambda b. What is the coefficient of this parameter? So direction ratio is I plus j plus k. If I write in component form, I would write 1, 1 and 1. So direction ratio is 1, 1 and 1. Similarly, can I draw my another line L2? Okay, what do you say about that? Okay, let's say this is my line L2. It passes through. Can you tell me the point? Yeah, component wise 0, 1 and minus 1. So my line passes through 0, 1 and minus 1. And what is the direction ratio of the same line? Yeah, from here, what is the coefficient? I coefficient is 1, j is 0 and k is 1. So 1, 0 and 1. That's the direction ratio. Okay, 1, 0 and 1. Okay. Now, before reading further, can you see that these two lines are not parallel, right? Because direction ratios are different. They are not parallel lines. Moreover, what is? They are skew lines. They are not going to meet either. These are 3D lines. Okay. Don't assume that these are 2D lines. They are going to meet. No. Okay. These are 3D lines. They are skew lines. The lines which don't meet each other, we call them skew lines. Okay. And if you want to check how do I know that they don't meet, you can try solving the two equations. Okay, you equate this to this, you don't get any value. Okay, so they are not. Anyways, they're talking about distances between them. So if they are meeting, then distance would be 0. So there is no problem then. Okay, so they are skew lines. Let's read further. Let X be a set of all the planes that contains the line L1. Okay, so what do you think? Containing the line L1, how many planes can you have? Let's say I draw this plane. Okay, that contains my line L1. Okay, this plane. Okay, someone might draw some other plane. Okay, let's say someone draws this plane. Okay, that contains line L1. Because you can look at this line as a stick. Okay, and you can, let's say you have stick a cardboard to that stick. Okay, and now if you revolve, to rotate the stick, there are so many cardboards. I mean, different orientations. Okay, all those are giving you all the planes. Okay, so there are so many planes here. Okay, now they are calling X is set of all such planes. Okay, H belongs to X. H is the plane. Now they are saying that distance between the line and the plane, that is dh. Okay, dh is distance of the plane from that line, that is dh. Okay, they're saying smallest distance. Distance means smallest distance, right? Nothing more. Okay, so distance between the line and the plane is dh. Now they are looking for the max value of this. Now which plane among all these infinite planes is going to give you the max value of this, the distance? Okay, they are calling it the plane to be h naught, and they are looking for dh naught. Okay, what do you think? Yeah, when do you get the maximum distance between the line and all these planes? Yes, do you think? Yes, the plane would be parallel to that line, then only you will get maximum distance. Okay, that means the plane is looking like this. Okay, it is parallel to that line. Now once you know that the plane which you are looking for, that means h naught plane, that is parallel to this line, can you find the equation of that plane? Let's do that. Yeah, so let's do. So this is your plane you're looking for. We are calling it h naught. It is passing through 0, 0, 0 because it is containing this line L1. Remember? Okay, 0, 0, 0, and the line direction ratio is how much? 1, 1, 1. Right? Same thing. Okay. Now this plane is also parallel to the other line. Okay. What is the direction ratio of this other line? 1, 1, 1. Oh, sorry, 1, 0, 1. Okay. Now, if you want to write equation of this plane, what do you need? Equation, direction ratio of the normal and a point on the plane. Okay, point is already known. Can you get the direction ratio of this? It is perpendicular to both these lines, isn't it? So that means the cross product of these two is going to give me the direction ratio of the normal to that plane. So let's get going. Get the normal. So what do you do? Cross product. Okay, so ijk 1, 1, 1, 1, 0, 1. Okay, let's get the, okay, so you get this is 0. So you get I minus k. Or component wise, if you write, the direction ratios are 1, 0, and minus 1. Good. Now let's write equation of the plane. So okay, it passes through 0, 0, 0, and direction ratios are 1, 0, and minus 1. So what is the equation of the plane? Ax plus by plus cz is equal to 0 because it passes through origin. A is what? This. Okay, A, this is ABC. So ax plus by plus cz. Okay, so you get minus z is equal to 0. So your equation of plane is this. Okay, I hope you know. Okay, ax plus by plus cz is equal to 0. Here these are your a, b, and c's. So you got equation of h naught. All the job is done actually. Okay, if you look at the question, you got the equation of h naught. Now what are they asking? You see the value of dh naught. What is dh naught? Distance of this plane from this line. Now they are parallel, right? So take any point on this. So you want distance between this point and this plane. How do you get the distance? This is the formula which you know. So let's use that to get distance between this point and this plane. How much do we get? That distance we are talking is dh naught. Okay, so instead of x you put a 0, there is no y, and then what do you get? Instead of z you put minus 1. So 1 over under root a square plus b square plus c square, that is root 2. So dh naught you got to be 1 over root 2. So let's come back here. So my p is matching to 5. Okay, 1 over root 2. Okay, distance between this point to h naught, again just the point has changed, right? Instead of this point you want what? 0, 1, 2, right? So what happens to the distance? Just let's write d here. So from this point to this plane, the distance would be, instead of x 0, instead of z you are going to put a 2 divided by under root, again a square plus b square plus c square. So you get just 2. Okay, so this distance would be root 2. Now the third, what are they asking? So this is root 2. Fourth, okay, they asking the third one, does distance from origin to h naught. So again the point has changed from 0, 0, 0 to this. Okay, what do you think it is? Origin is on the plane, right? So there is no distance, so distance is 0. Okay, you can use your formula, but we know the distance is 0. So r matches to 3. Okay, we are actually done. That b is the option. Okay, but let's do the last one. The distance of origin from the point of intersection of all these is equal to z, x is equal to 1, and what is your h naught? X minus z is 0, that means x is z. Okay, that means x is 1, so z is also 1, which is same as y. So that means what is the point they're asking for? Distance between 0, 0, 0 and 1, 1, 1. And what is that? Distance between these 2 points, yeah, it is root 3, right? Matches to 1. Okay, so this b option is the correct option. Easy question, right? I will see you with another soon. Bye bye.